So here's a problem I came across the other day. I thought it was interesting, and I'll tell you why in just a minute. Suppose 1 pound of an item costs 2/3 of a dollar. How many pounds can you buy for 3/4 of a dollar? Well, fact. We could buy 1 pound for 2/3 of a dollar, as given to us in the question. Well, this means we could buy a half a pound for 1/3 of a dollar. We're just cutting those givens in half. This means for $1 then, we'd have to multiply that by 3, so I'd have 3 times 1/2, or 3/2 pounds that I could get for $1. Well, let's now imagine that I want to get this into fourths of a dollar. So for 1/4 of a dollar, I could get 1/4 of 3/2, which would be 3/8 pounds. But I really needed 3/4 of a dollar. That was given in the question. So I really need 3 of those 3/8 pounds, which is 9/8 pounds, which answers the question for me. We look back though and we see that really we ended up multiplying 3/4 times 3/2, and these were almost the numbers that were in the question, with the exception that the 3/2 was the reciprocal was given to me in the form of 2/3. So maybe this is a division question. 3/4 divided by 2/3 would be telling me how many 2/3 are in 3/4, which when I look back at that original question is really what it was getting at. I should have seen this as a division question, yet it's solved by multiplication. So is this some kind of crazy new math? Well, let me walk you through how I came across this problem. A few days back, Ron Paul put out a press release, if you will, that says, opt out of the Common Core, opt into the Ron Paul curriculum. So for just a moment, I did exactly that. I jumped over to the Ron Paul curriculum and I took a look. And I saw that for 5th grade math, Ron Paul was recommending Ray's New Practical Arithmetic. So I clicked on the link and I went to Ray's New Practical Arithmetic, and I saw that Ray's New Practical Arithmetic really wasn't new at all. It actually came from Joseph Ray, and he published this book back in 1877. And knowing what I know about the learning of mathematics, I know that division of fraction poses a particular challenge to many people. So that's where I went to take a look and see how is Ray and his New Practical Arithmetic handling division of fraction, since Ron Paul is recommending that I go this way. Well, I scrolled down and I got to this problem down here. Problem number 4. At 2/3 of a cent for 1 apple, how many apples can be bought for 3/4 of a cent? And this may look familiar because it's the question that I just asked you, except I used pounds and I used dollars instead of cents and apples, so that the problem would be a little more ready for the 21st century. Well, check out how they walk through this. Check out how Ray recommends that we solve this problem. That we think about it this way. For 1/3 of a cent, 1/2 an apple can be bought. And for 3/3, or 1 cent, you can get 3 times that 1/2, or 3/2 of an apple. Then, for 1/4 of a cent, you can get 1/4 of 3/2, which would be 3/8 of an apple. And then we need 3 times that for 3/4 of a cent. So we get 3 times the 3/8, which gives us 9/8, or 1 1/8 apples. And even back in 1877, the author intended that students would be able to follow through this solution and make sense of it and have the understandings necessary to get through it. In the preface of the book, Ray himself outlines a couple of principles. He says, first, every principle is clearly explained by an analysis or solution of simple examples. Yeah, that was a simple example from which a rule is derived. And Ray is going to derive the rule for division of fractions soon after that example that you just saw. And his second point, the arrangement is strictly philosophical. No principle is anticipated. The pupil is never required to perform any operation until the principle on which it is founded has first been explained. That is, that his procedures, if you will, the notion of, we're going to eventually divide these fractions by multiplying by the reciprocal, but that's going to first come out of an understanding of how we get to that point. So why does Ron Paul want to throw away the Common Core? Well, for math, he says, reform math turns real mathematics on its head by focusing on abstract thinking instead of traditional concepts like addition and subtraction. So I thought I'd go to a Google search and just type in abstraction. The first definition was the quality of dealing with ideas rather than events. But it seemed to me that Ray's arithmetic curriculum was doing pretty much that. This sounds a whole lot like what Ray was trying to accomplish. clear back in 1877. So let's take a look at how the Common Core addresses this notion of abstraction. We'll find it in mathematical practice number 2, that students be able to reason abstractly and quantitatively. And what we see here is that we want students to have the ability to decontextualize, that is, to abstract a situation and represent it symbolically and manipulate those. We also want students to be able to contextualize, that is, put the mathematics back into context. I kind of like to think of it this way, that we have some task we want to deal with. I need to be able to take that task and I need to be able to turn it into the symbolic math and do the math accordingly. But I also need to be able to take the math that I do and apply it back into the situation. With the quantitative reasoning that the students are being asked to do in the Common Core is to create coherence. That is, they should think about the units that are involved. They should attend to the meanings that are involved and not just on the computation itself. It looks like Ray himself wanted his students to think abstractly and quantitatively back in 1877. Are we creating students who can think through problems like this? Or are we just trying to create students who can do the same sorts of calculations and computations that can be done by a $1 calculator? To some, the idea that mathematics goes beyond computation to develop the ability to think abstractly and quantitatively, to include understandings, ways of thinking, attending to the quantities and the operations that we're dealing with, to think on these things as some kind of crazy new math. But this math is neither crazy nor new. It's just simply math. We just haven't seen much of it for quite some time.